Okay, we have section 4.1, question P3, and we're looking at the concept of simple random sample here among a class of 30 students. Now, when you approach these, I think our brains naturally want to go towards why is a sample random or what patterns might be in there, and those are great follow-up questions. But for determining whether something is random or not, it's a simple rule of is each possible sample, each combination of people in the population equally likely to be chosen in that sample. And that combination is an interesting part that we'll get into in part C here. We're not just saying is each person in the entire sample equally likely to, or in the entire population equally likely to be chosen, but is each set of however many you're putting in your sample, so if you're doing a sample of 6, is each set of 6 students equally likely to be chosen? And if there's a certain set of 6 that could never be chosen, then that's certainly not simple random. Or if one is more likely to be chosen than another, like we'll see in part B, then that's also not a simple random sample. So part A, select the first 6 students on the class roll sheet. Again, although intuitively that may seem somewhat fair, it's certainly not a simple random sample. So a simple random sample of 6 students, we should be equally likely to get any combination of our 6 students in the class. In this case, the last 24 students on the roll sheet have no chance of getting chosen, so this is certainly not simple random. On part B, randomly choose a letter of the alphabet, and then say we choose the letter K, then we're going to take a randomly choose from the people that begin with K. So this is not a random sample. This one's a little harder to see. So in this method, technically any one of the students in the class could get chosen if you happen to choose the letter that their last name begins with, but it's not equally likely, because think if you have a letter like S or T or something that is more common, you're going to have more students with that letter, versus if you get a letter like Z or X or something where there's probably not as many students with that last names beginning with that letter. So what would happen is if you choose, say, Z, then that might limit you to the only student in the class with the last letter Z, versus if you choose an S, there may be 7 students and each one only has a 1/7 chance of being chosen then. So because we don't have that equal distribution of last names, then it's not going to give us an equal chance of choosing each student. Part C, so we have 6 rows of 5 seats each. Choose a row at random and select all students in that row. This is not simple random sampling because, so here's a case where, yes, we could choose each student or any given student, and yes, any given student is equally likely to be chosen, but we can't get every combination of 5 students in the classroom. For example, if there's 3 students, say the first 3 students in the first row and the next first 2 students in the second row, there's no way that this sampling method would combine those 5 students together. And so because of that, we certainly don't have an equal chance of selecting any potential group of 5. So again, those first 3 students in the first row and first 2 students in the second row, that makes up a group of 5 students. That student could never get chosen. In fact, we only have 6 possible groupings of the 5 students, which would be the 6 different rows. Part D, we have 15 males, 15 females. Assign the males 1 to 15, females 16 to 30. Use a random digit table to select 6 numbers from 1 to 30. So here, even though we're dividing the class into males and females and then giving them numbers, that's not affecting how we're actually choosing. So we're still choosing 6 numbers randomly between 1 and 30, so we could still end up with 6 males, for example, or 5 males and 1 female. The division of the males and females really did nothing here in terms of our selection process. The main part here is we had 30 numbers and we randomly chose one of them. So that, in that case, or six of them. In that case, any combination of 6, say students 1, 3, 7, 8, 11, and 19, is just as likely to be chosen as the numbers 1 through 6 or the numbers 25 through 30. Part E, if the class consists of 15 males and 15 females, so we're going to do the same first step, but now we're just going to get 3 of the males and 3 of the females. Even though we're choosing randomly from the males and from the females, so even though each student has equal chance of being chosen, we don't have an equal chance of choosing any group of 6 here. In fact, take the first 6 males. There'd be no way, 0 probability, that we could get those 6 males in our sample, because we're forcing ourselves to have 3 males and 3 females. It's not necessarily a bad thing. This is stratified random sampling, but it's certainly not a simple random sampling because we're taking away some of the power from the randomness.